start. So Nicolas and I, we will talk about rapid diagnostic test. And as we only have a few minutes, it will rather be quick overview than an extensive review. And I will do the easy part, which is to introduce the different tools that are available. And then Nicolas will show you some results of some evaluation that we made. And he will give you some insight, also some thoughts about how and when to use those diagnostic tests. So as we speak, the least we can say is that the number of detected cases is on the rise, although hopefully the number of admissions and deaths are growing slower than during the first wave. This difference with the first rate is at least partially due, and even if the situation is not ideal, to the fact that we now have a larger testing capacity, allowing us what we couldn't do during the first wave, what we were not able to do, which is screening and testing ambulatory symptomatic patients, on the contrary of the first wave. So what are the tools that we have at our disposal for fighting this second wave? These tools can be separated in two groups. One group, which is in blue on the slide, is the group of the lab-only tests. And the second group, which is in green on the slide, is the group of point-of-care friendly tests. So as you well know, historically, the first tool to be available was the classical real-time RT-PCR, which is by definition an in-lab only test, and which is still considered as the gold standard test. It allows good sensibility and a good specificity, and real progress have been made going from manual techniques to high throughput, completely automated system now. Unfortunately, these tests are still performed by batches, and so that reaching a global time to result in less than 24 to 36 hours remain quite difficult. The second waves of tests that were available are, of course, the antigen lateral flow immunoassays, which are by nature designed to be used as point-of-care tests. They are really rapid and easy to use with a result in a few minutes, and they are cheap. However, all these advantages are in the expense of sensibility. As they are made and by nature made to be used as at piece work, they can't be used to test a large amount of samples at the same time. More recently, new tests have been developed, which are mirroring, I would say, the two first. And these are, on one hand, rapid molecular tests that are designed to be a point of care. They allow a rapid result, almost as rapid as lateral flow assays. And they have the same sensitivity, or almost the same sensitivity as the classical PCRs. However, they are not cheap. And as for lateral flow assays, the flow rate still is low, and they cannot handle a lot of samples at the same time. The last category of tests on the list are the automated antigen detections, which are the in-lab solution for antigen testing. They can reach rapid results thanks to a high throughput. And another potential advantage is that they can give and they can allow quantitative results. So here, as you see, and you all know, is the first generation of lateral flow test in its two forms, the strip in a tube format and the strip in a cassette format. I won't repeat what I said on the last slide, but I may maybe add that the fact that this tool is cheap and does not need any instrument to be used, it is a very useful solution to use in low-income settings. And now let's introduce the second generation of lateral flow tests. J'arrive plus à changer. Oh, sorry. So this first generation lateral flow test was tested in 3 laboratories in Belgium during the first wave. And these laboratories demonstrated its excellent sensitivity and positive predictive value. However, the sensitivity didn't reach 60%. And this sensitivity, in fact, is highly dependent on the viral load present in the sample. Finally, this test ended quite criticized during the decreasing phase of the first wave in Belgium, mainly due to the fact that it missed quite a lot of medium to weak viral loads patients. So now we have second generation coming. And this second generation of lateral flow assays present 2 major evolutions. They are designed to be used on dry swabs and with the help of reading devices, which give them 2 advantages, which are a better traceability and a better sensitivity. And indeed, the results of the first evaluations we have that were performed with this test are really encouraging and showing nice results. However, these evaluations were made on patients that were at the early stages of the disease. So this leads to a very puzzling question that I will leave Nicolas to answer to. And the question is, are really these second generation tests really better, or isn't it because the best results that we observe are due to the fact that we are using them on a more specific and suitable population? A last technical remark before letting Nicolas develop on that is that all the results of PCR that Nicolas will show you are, of course, results that we obtained with our PCR solution, which is the 2000 solution from Abbott. This solution, as the majority of PCR that are used to detect SARS-CoV-2, targets 2 genes, but the exception with the M2000 is that these 2 targets are built on the same color panel, which means that the CTs that we observe are observed earlier and that they extinguish earlier also. So no direct transposition or comparison can be made with other studies made by other solutions for PCR. Nicolas, let me continue.
Okay, that's good now. Okay, good morning. So I will continue with introducing you to our recent results that we did during the week about the comparison of 4 rapid diagnostic test solutions that we tried from Abbott, BD, Coris, and Roche. So as Marie said, these point-of-care tests are supposed to be used with dry swabs, but to compare them, we use 99 UTM samples from our routine that we use as a proxy following each manufacturer instructions. So there are some difference between the quantity of UTM that the manufacturer wanted us to use. So it's very difficult to say that these results are very, very similar. On another hand, we also use like a large range of CT to see the sensitivity and specificity. So we found out that we have a limit of detection for CT under 13 to 18 on 32. And that gave us sensitivity which are pretty low, from 46%, 49% for Roche to 36% for BD. But as you compared with the quantity of UTM that we are using, it's quite follow the same order. So is it really a difference of sensitivity, or it was just depending on the amount of sample that we are using? All in all of these kits had a very good specificity with 100%. So indeed, a very good positive predictive value. And adjusted on the current prevalence of yesterday, the negative predictive value was 85%. So that leads me to the first small conclusion with this presentation, that these rapid diagnostic tests are not fitted for laboratory testing. They should be used on what they are supposed to, what they were built to, as a point of care. So to assess what can be the best target population of this rapid diagnostic test, we decided to compare the CT of the different population that we have in our laboratory. And we categorize the patients in 4 different categories according to the INAMI refunding criteria. So we divided in 4 populations, which are the symptomatic outpatients on one end, the patients which required admission in hospitalization. We had the high-risk contacts. So, and what I called the mandatory screening, that was tracing which were made in a context of travel, either for people flying in or flying out of the country regarding the different regulation which was asked. So we found the real significant difference with higher viral loads, with the highest loads for symptomatic outpatients, but also for high-risk contacts just after. Whereas we have the lower viral loads for patients requiring admissions, and patients we were there for screenings while asymptomatic. So the explanation that we can find here, that the symptomatic outpatients are usually at the beginning of the disease with high viral load, whereas the hospitalization happens in the late stage of the disease when the viral load is lower and difficult to get with antigen test. Interesting thing also we checked these days, that the evolution of the median CT of the population. Sorry. Which are, there is a trend of the decreasing, but also with the increase of number of people. So we probably now have a lot of new symptomatic outpatients. So maybe it's sorry, apparently I don't have any more. I will try to, I lost. C'est revenu. Okay, sorry for the technical issue. The trend is that the median CT are currently decreasing. Ok, j'essaie de juste partager l'écran. Okay. So with the decrease of the CT and the increase of number of people, we now have a good part of the population which have low CT below, with 75% of the population below 21 of CT, which can really improve the sensitivity of antigen test. But also when we know that the false negative, there's a quite important part of false negative, we also can decrease the negative predictive value. So what about another solution that we had the chance to try, which is the automated antigen detection that we tried with the lumipulse from Fuji Radio. It is a quantitative detection immunoassay that I'm losing again. I'm very sorry. I don't know why I always get kicked out of this. Okay. So we had the chance to try this assay, which is also the idea is to find the antigen, but with a more I think you can hear me. Okay. Okay, now there is sound again. So we tried this instrument which can provide us quantitative detection of antigens. But there are some requirements because these instruments are normally used in biochemistry for detection of proteins or hormones or procalcitonin, for instance. So there is the need to determine the cutoffs because of the type of sample. There are frequently a gray zone because the samples we cannot control currently the UTM due to shortage. We have difficulties with some which are more viscous. So there is some need for centrifugation. And we also need to assess how to use this instrument in a biosafety area because these instruments are usually in a level 1 laboratory. But the performance are very interesting because with different cutoff, with a cutoff quite low at 1.96, we still have very good sensitivity of 77%, but with a specificity of 77%. So we have also some false positive. But when we increase the cutoff, we don't have any more problem of false positive, and we have a very good specificity, but sensitivity, which is now only at 64%. But if we change our mindset and we want to think about how to use these instruments to detect not anymore only positive, negative, but if we want to detect the patients which are producing a lot of virus, we have the highest viral load. So if we put the threshold at the CT at 20 on 32, we have a ROC curve, which is way better with a very big area under the curve. And now we can have different things. We can think about different cutoff. We can say that below 1.32 with a very good sensitivity, we have patients with very low with no viral loads or with very low and probably not contagious patient. And if we are upon 20.3, we are sure that the patients are infectious. And in between, we have kind of a gray area that we need to assess the risk and we need to assess the necessity to make additional tests. So this kind of strategy can be very important on the impact on surveillance, because as you can see on this paper from Mike and Mina, there is a new strategy which are thought now to check if it's not better to have low analytic sensitivity to detect the patients which are at risk of being infectious, being contagious, and more than doing some PCR that we cannot do on a frequent mode, and that we can totally miss the contagious part, and we can even be positive when we are after the infection and when the person is not anymore contagious. So the timing of the testing, as we saw before with the rapid test, is really the key for the choice of the best method.
So now to go through, quickly through the Rapid-PCR system, as Mary said before, they are developed and they have very good sensitivity. The problem now that we have not a lot of PCR available. In Europe, we have for the moment, on my own knowledge, only the Gen Expert SARS-CoV-2, and maybe we are going to have the cobas Liat. But both of these instruments are with difficulties to get reagent, and so it's very difficult to do that, and the cost is very high. And once again, these instruments are thought to process one patient at a time, so it's very low output. There's also some multiplex PCR for severely ill patients like FilmArray, but there's also the same, the FilmArray, which include SARS-CoV-2 is with difficulties about availability in Belgium. All of these PCR tests have very, very good sensitivity and are quite the same as the large PCR platform. But what's very interesting that when we use this kind of PCR system, that is, for instance, the example that we had last winter. It was using the Liat for influenza and RSV in the emergency room, where we can have the result for influenza and RSV in the emergency room in 3 hours. We still needed 24 hours for coronavirus. So on an individual point of view, if you need to manage the flux of inpatient at the emergency room, it can help to avoid that people getting stuck in some ward that we are not sure if they must be in isolation or not. And that's also, we saw that it helps a lot the physician to decide whether the patient should be in isolation or not, because we've tested that they are following strongly if there should be an isolation or not. And we saw with influenza that it can even decrease the number of isolation, but with better isolation for people who really need it, and less isolation for people who don't need it. In conclusion, so rapid diagnostic tests are probably their place in an integrated diagnostic algorithm. So the target, as I say, we need to respect what they were intended to. So we need to take the symptomatic outpatient for less than 7 days and probably even less than 5 or 3 days. And maybe we can use them, but it's not been evaluated yet for high-risk contact if we just want to know that can you get out of your quarantine after 7 days or not. But we need to change our mindset in Belgium because the laboratory is not probably the best operator for that. It's probably in the emergency room, it's probably at the general practitioner's level. So that also means that we need to change the current regulation. And we cannot do this without being very precise about when these tests should be timed and what the interpretation of a negative result. Antigen testing can also be used, as we saw, for surveillance, maybe, to assess the contagiousness of the patient, and maybe in the screening for nursing home in patients which are not hospitalized for coronavirus. But this needs a solution which needs a big, large throughput, so maybe automation. And what we wanted to say also that now we have very high volume of PCR requests for patients, but maybe we need now to keep the PCR for the patient who create admission, because maybe now with all this evolution, we really need to diagnose people in hospitalization first, and then afterwards we'll think about enlarging the possibility. And that's why rapid PCR has probably a key role to play in the management of inpatient, like in the emergency room or for the direct entry intensive care unit, to avoid late diagnosis and help with the isolation. So thank you very much for your attention, and I'd really like to acknowledge all of the people who helped for this study, and especially Fanny and Cyril, which have been very helpful. Cyril, especially this last day, because the very last results are from 2 days ago. So thank you very much. And thank you also for the partner which provide the reagents.